Number 8. Oh, that's quite a long one. A quantity y is inversely proportional to the square of x. Okay, we have x2, y2. What it means by inversely proportional, it means if y increases, x decrease. When y decrease, x increase. So that kind of difference. One go up, another will go down. But if another one is going down, then this one will go up. Okay, this will happen when we have this kind of type, right? If x increases, y will be decreased. And if x is decreased, y will increase, right? Now we have x equal to 2 and then y equal to 2. The equation connecting x and y. Okay, let me see. So just now it says y is inversely proportional to the square of x. Okay, I shouldn't put this as 1 because we don't know the number. So when y is 2, x is also 2. Then a is 8 for yep. So the equation is fx equals to 8 divided by x squared. There is number 0.1. Point 2, sketch the curve of fxy. Label clearly any asymptotes. Okay, asymptotes is this. When you have a kind of curve like this way, it will keep getting closer to this x-axis or y-axis, but it will never touch. So on this part, the x will not be 0, will never be 0. Okay, that's what it means by asymptotes. Usually we'll have something like this as well. So it's just that within that range here, but then there will be a gap for the 0 because the x can never be 0. It's infinite, getting closer. Then after this particular point, the graph will start functioning again. That is what it says by asymptotes. Okay, now usually asymptotes will be this point. So when x is 0, let's see. From here, you can know that x should never be 0, right? But in this case, we need to find when the number is not real anymore, because that means at that point, at the point of x is 0, which is cannot be solved with real number, then this is the part where we will reach asymptotes, because there will never be a real number for it. So when x is 0, y will also be 0. This is the asymptotes. Okay, I think it's the same graph as this. We need to find another equation. So let's say x is 1 using this equation. Sorry, this one. Y, which is 8 divided by x squared, will be 8. And x is minus 2. Y will be 4. Am I correct? So I'm minus 8. Sorry. X. Oh. 2, 4 by 2, 2. And then let's take another 2. Y will be. Okay, this should be the same. I mean the y. So minus 1 and 8. It's plus. Minus 2 and 2. So I think we can use this diagram. 1, 2. Oops, minus. Since the asymptote is when x is 0 and y is 0, so they will never touch this point. We will have 8. 8 is when 1, like that, here, and then only you draw the curve. Okay, using this point. Sketch the curve. Okay, this is number 0.2. Now point 3. A is fx. It means the equation will become this, right? Same again when x is 0, which is impossible, we'll have here. Then we find this. Why I put this number? Because it's just the closest to the asymptotes, right? If it's too far, then it's harder for us to do it. When x is 1, y will be minus 8, yes. 2, y will be minus this, and then when x is minus 1, it's squared anyway, so okay. 2 squared 4, this is minus 2 and minus 2, yep. So we have 1 minus 8, this one minus 8, and then minus 2, 2. It asks for us to label each curve with its equation, which is this one. It's really important for you to understand the question first before you do anything, okay? Label clearly any asymptotes, which is this, of any points of intersection with the coordinate axis. Okay, there will be no intersection of the axis in this point because we have the asymptotes, right? I mean, we have the asymptotes here. So it means it will never touch x equal to 0. It will also never touch y equals to 0. Then we have 1. Oh, this one going out. Minus 8, 2, minus 2. So we have this. Minus 1 is with this here, here. Okay, so the graph will be like this. Asymptotes will still be the same. B. I think there is one that let me just check it again. Okay, when fx plus 2 okay, what we have first is the ouch, let me think for a while. X is 1. Okay, means from this one we have to put x am I correct? X2 oh no fx plus 2, so 8 will becomes plus 2. This will be the equation. Now when x is 0, which is impossible, y will be 2. So this time the asymptotes of y is not 0 anymore. It means x is 0, the curve will never touch this line. But as for the y, it will start at 2. It means, okay, there won't be this. So let's try to find the points. 1y is 10. 2 minus 2. Okay, when x is 2, for 2 divided by 2 it will become 4. So we have this. This will be the same as well. Minus 1, 2, 4. Okay. We will never touch this line. That's why if you realize it, I don't create the line over this. Why? Because we have the asymptotes at 2. It means we will never go to this point. That's why we close it off just there. Okay. This one still yx. When x is 1, y is this. When x is 2, y will be 4. Same thing here. Oh, sorry, the point is there. This will be the, what is it called, asymptote, and then the curve and the equation. Now for number C, can you just like try yourself first, and I'll discuss if you are still confused with this one. Feel free to just pause and then try to understand each of the question. Okay, point 4. Another function is given as gx equals to x minus 1. It needs for us to solve fx minus 3 plus 2 as gx. So we can just put in the number from before, from the equation of fx is 8 square. Okay, means x minus 3. Okay, so fx minus 3, which is 8x minus 3 square plus 2 equals to x minus 1. How can we simplify this? X minus, okay, x minus 3 square equals to x minus 1 minus 3. Okay, x minus 3 square will be times, oh sorry, this is 2. So we have x minus 3 power to 3, 8. X minus 3 with square root 3 of 8. X is 2 plus 3. It's 5. This is number, the result. B. Hence find the coordinates of the points of intersection. Oh, okay. Points of intersection, it means, well, this one. When we put in y to y, this means the x is the intersection part. Okay? Because the same y will collide with the same y. So we have x is 5. We just need to find the y. X minus 1, 5 minus 1. So the intersection point is 5 and 4. Right, that's it for number 8. Quite a long one.